Okay, first things first. I want to show you what you should not do. Okay? So I want you to write it down, and then we're going to put a big X through it, and we're going to write don't do. Okay, I'm going to do it in orange, a color of warning. Okay? So, don't do this. Here's what you should not do. You shouldn't look at this and say, oh, well, 1 and 2 are series and 3 is parallel. So R equals 1 plus 2 plus 1 over 3. Don't do that. Because someone else might say, oh, no, it's not like that. 2 and 3 are in parallel and 1's in series. So they would say R equals 1 plus 1 over 2 plus 1 over 3. And someone might say, no, you're all crazy. No, remember for series circuits, oh, here we go. Remember for parallel circuits, it's 1 over R. Okay, so it's 1 over R equals 1 plus 1. You can see where I'm going. You could play this game until the cows go home, and you're going to have 5 different people get 5 different things. And guess what? You can't all get a different answer. So don't do these things, okay? What I mean is don't do this. What this is, don't combine series and parallel. Don't do that. Don't combine them. Okay? Either it's series or it's parallel. Now, you might be saying to yourself, but Mr. B, this is clearly both. And yes, you're right. It is clearly both. What I mean is you can't do series and parallel at the same time. Not that a problem can't have series and parallel. So let me show you how to go about doing this. So the first thing we need to do is we need to do equivalent resistance, and we need to do it by combining these things together. So I'm looking at this circuit. I'm like, well, I mean, 2 and 3 are parallel, but 1 and 2 is also series. But I could also say 1 and 3 are series. So what do I do first? Do I do 1 plus 3 is 4? Do I do 1 plus 2 is 3? Do I do 1 over 2 plus 1 over 3? I'm so confused! So here's what you do. You do something called the little physics train that could. Okay, the little physics train that could starts at the train station, the choo-choo station of the battery. And he goes choo-choo-choo-choo-choo-choo-choo-choo-choo-choo, and he just keeps on going. And when he gets to a split in the circuit, then he goes through one or the other. And I'm going to draw the 2 options that he's going to do. And now he's back to the same spot, so he finishes up his trip. Okay? Little physics engine that could. Now you might be saying to yourself, Mr. B, that doesn't help me at all. Well, here's how it helps. What you're looking at is you're saying, what things absolutely have to happen? I absolutely have to go through the 1 ohm resistor, because that's where I go from the battery. And then I absolutely have to go through 2 or 3. I don't have to go through them both, but I have to go through one or the other. So here's why that's helpful in figuring out if it's series or parallel and which ones to do first. I can't say 1 and 2 are series because I don't have to go through 1 and 2. Right? Series means things are directly connected. I have to go through this, then this. I don't have to go through 1 and 2. Likewise, I don't have to go through 1 and 3. So 1 and 2, 1 and 3, those are not series. However, I have to go through 2 or 3. I have to go through one of them. That tells me that 2 and 3 are parallel. I'm going to call this circuit A. So I'm going to find 1 over RA. And that's 1 over the first resistor, which is 2, plus 1 over the second resistor, which is 3. And again, the reason why I combined these 2 together and not 1 and 2 and not 1 and 3 is because I absolutely have to go through one or the other, but I don't have to go through 1 and 2. And I don't have to go through 1 and 3. You always ask yourself, what do I absolutely have to do? And those are the ones you combine together. Okay, so common denominators here. I'm going to make the common denominator 6. So 1/2 in 6 is 3/6. Okay, and 1/3 in 6 is 2/6. Gives me 5/6, but remember that's equal to 1 over RA. I don't want that. I want just RA. Flip the top and the bottom. That gives me 6/5 or 1.25. Either one is fine. Or sorry, 1.2. Either one is fine. If you want to do decimals, you would get 0.5 plus 0.3 repeating would give you 0.83, or 0.83 essentially. And then you do the inverse button of that, and that'll give you your answer. Now, I'm not done yet. This is only the resistance equivalent for these two, not for the whole thing. So what I'm going to do is I'm going to redraw my circuit. 3 volts. Here's my resistor 1. But now, instead of 2 resistors connected in parallel, I have one resistor, RA, which has a value of 6/5. Or 1.2, whichever is easier for you to deal with at that point. And now it's pretty obvious what's going on. Now I can tell for sure that this is series. So I'm going to combine this as series. REQ for the whole thing now is equal to 1 plus 1.2. If you did 11/5, that's also fine. But there you go. There's the equivalent resistance. So I had to do it in 2 steps this time. Sometimes it'll be more steps just depending on the problem. Now I'm ready to do the equivalent current. So V equals IR. So the voltage is 3. The current is I. The resistance is 2.2 or 11/5, whichever you're going with. And when we do this, we get 15/11 or 1.36, whichever way you're going. And then the last thing says the current and the voltage for the 1 ohm resistor. Now you might be saying to yourself, well, Mr. B, on the front side, when we did the practice, we identified it as series or parallel. And we said series things have the same current, parallel things have the same voltage. So what's this if it's all of them, if it's series and parallel? Well, you just look at the 1 ohm, and you say, because that's the one I'm asking about. Okay? I'm asking about the 1 ohm, so I only look at the 1 ohm. And I say to myself, what is that with relation to the battery? Is it series with the battery, or is it parallel with the battery? It's series with the battery, so that means it has to have the exact same current. So I'm going to identify this as series. Okay, so voltage for 1, current for 1. Anything in series has to have the same current. So if the current for the whole thing was 15/11, then the current for this one is also 15/11. And then the voltage, V equals IR. Okay, times the resistance, and this is the resistance, just the 1 ohm. So its voltage is also 1511s. Again, that's only because it's 1 ohm. There we go. One last thing to point out. I will always give you this to solve for a resistor that is clearly series or parallel with the battery. Okay? So, for example, I wouldn't give you 2 ohms because it's not really parallel with the battery, because look where it's connected to. It's connected to 1. It's not connected to the 3 volts. Now, you all are capable of figuring out what it would be. You would have to find this voltage first, which you did here. And then you know that this gets what's ever left over. So you're capable of doing it, but we're not going to go that far down the rabbit hole. That's for a different day and a different time.